guys, so here we are with the second question of the exercise 1.1 for the chapter real numbers. So the second question is, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. So in order to solve this question, let us take two unique numbers, say a and b, such that a is greater than b. Then on dividing the number a by b, two unique numbers q and r will be obtained where q is called the quotient and r is called the remainder. The relationship between the numbers a, b, q and r can be represented as a is equals to bq plus r. Provided with the condition on the value of r is that r value can be greater than or equal to 0 but less than b, where b is the divisor. Now let us suppose in this case b is equals to 6, that is the divisor be equal to 6. Then a will be represented as 6q plus r. And in this very case, the value of r will be r can be greater than or equal to 0 but less than 6. That is, the divisor in this case is 6. So r value can be greater than or equal to 0 but less than 6. So the set of value which r can take is 0, 1, 2, 3, 4 and 5. Using these values of r, which means that a may or may not be perfectly divisible by the number 6, leaving the remainder 0, 1, 2, 3, 4 or 5. Using these values of r, the number a can take the form 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. What it means is that if the number a on dividing by the divisor 6 leave the remainder 0, then the Euclid's division lemma will be equal to a is equals to 6q. If 1 is obtained as a remainder, then the form a will take is 6q plus 1. And if 2 is being obtained as a remainder, then the form of the number a will be 6q plus 2. If 3, then 6q plus 3. If 4, then 6q plus 4. And if 5, then it will be of the form 6q plus 5. Now, on clearly observing the form 6q, 6q plus 2 and 6q plus 4, what common thing which we will observe in these three forms is that these three forms are the multiples of 2. How we can say that these are the multiples of 2, as these three forms can be written as 2 into 3q, 2 into 3q plus 1 and 2 in the bracket we will be left with 3q plus 2. Since these three forms are the multiples of 2, so we can call that these will form even numbers. And the forms which we left are 6q plus 1, 6q plus 3 and 6q plus 5. These three forms are not divisible by the number 2, which means that these three forms are not multiples of 2, which ultimately means that these numbers are odd numbers. So we can conclude from this step that any positive odd integer is of form 6q plus 1, 6q plus 3 or 6q plus 5, which means that these three forms are possible for the number to be an odd integer. This was all about for the question second of exercise 1.1. I hope this question is clear to all of you.